So let's think about another example where we can test a hypothesis. I think we're here now. So suppose we have a null hypothesis that there are a lot of dead people voting in our election in Georgia and Pennsylvania or wherever, and somebody asserts that the proportion of dead people is 5,000 out of 100,000, so 5%. 0.05 of all the ballots cast are dead people. So that's their assertion, that's their null hypothesis, and what we do is maybe we take a random sample of 1,000 voters and we check all the names of these 1,000 voters. And suppose that we find 2 dead, 2 out of 1,000. Look, we just did 1,000 and there's millions of voters. And in just those 1,000 we found that there were 2 who were dead. So should we accept or reject the null hypothesis that the proportion of dead voters is 0.05 in this recent election, right? So our sample proportion is 0.002, and what we want to know is, should we reject the null hypothesis that the sample proportion is 0.05? So we need to find the probability that we'd find a sample mean, in this case a sample proportion, as far away from 0.05 as 0.002 is far away from 0.05. So in other words, we can think about it where we have 0.05 and numbers like this here in this range are close to 0.05, but numbers in this range and in this range are far away from 0.05. So we want to know, what's the probability of finding numbers this far away if we took a sample. There we go. It's still working. I'm sorry. A little technical glitch there. So this is also far away, right? So so that's the probability of being out in these tails. So in order to construct our hypothesis test, to find that probability, we need to know what's the standard error of a sample proportion. And we can look that up. The standard error of a sample proportion is the proportion is the square root of the proportion times the sample proportion times 1 minus the sample proportion divided by n. So we have 0.002 times 0.998, which is 1 minus 0.002, divided by 1,000, which is our sample size, and that gives us a standard error of the proportion of 0.0014. So then we calculate our probability. So this number here, 0.002 minus 0.05, this is our null hypothesis, this is our actual sample proportion, and this is the standard error of our sample proportion. So that follows the standard normal distribution. So we want to find, well, what's the probability that we get a random variable that's less than that, right? So the probability that it'd be in this tail, and then we multiply that by 2 to get this tail. So that's why we have the 2 here. So 2 times this probability, we can look up this probability in R, just by typing in R, we type P norm, and then we would go P norm, well, we'd go 2 times P norm of what is it, 0.002 minus 0.05 divided by the square root of 0.002 times 0.998 divided by 1,000. The 1,000's in the square root too, right? So it's the square root's all that, right? And that gives us 5.19 e to the minus 253. 253 zeros and then 5.19. So that's telling us that if we took a random sample of 1,000 people and we find that there were 2 dead, there's no chance, virtually, right? There's of course always a chance, but it's 0.000253 zeros, that's the chance that the true the true population proportion of dead people is 5%. It's just not possible with given the sample that we have. So that's an example of a hypothesis test.